Welcome to our capstone presentation. Our presentation will address the feasibility study of Sorrento to Miramar Phase 2. On this project, we will look at two alternative alignments and determine which of these two alignments is the best alternative for the owner, Sandag. Our project team includes
Oscar de la Cruz,
Daniel Redondo,
Alexis Zapata,
Samuel Chordy,
and myself, John Harris. The LOSSAN rail corridor ties Southern California together and plays a pivotal role in the nation's transportation network. The LOSSAN Coastal Rail Corridor Plan is the overarching plan that dictates further developments along this corridor. This plan includes $1 billion over a 20-year budget for planned improvements in the San Diego area. In this report, we will evaluate a phase of this plan by looking at a section of rail called Sorrento to Miramar. The evaluation is going to determine which of two proposed alternatives is the most economical and environmentally sustainable. The purpose of this improvement is to increase freight and passenger car speeds through this segment and corridor in general. Our project is located in San Diego, just east of the Golden Triangle, north of MCAS Miramar Military Base, and south of Qualcomm Campus. It services the San Diego area and allows for transportation of freight and passengers. The stakeholders on this project consist of Amtrak, North County Transit District, the Department of Transportation, Sandag, and Metrolink. Our project includes the analysis of two alternatives. Here we see alternative 1.
The first of our alternatives is alignment 1, which is located on the south side of Carroll Canyon, just east of the I-805. This alignment lies along the current existing alignment. In order for these two alignments to run side by side, 700,000 cubic yards of soil must be cut. Due to these cuts, the soil at 3 locations become unstable and soil nail walls must be constructed to keep the soil from collapsing onto the tracks. If these conditions are met, the train can achieve a maximum velocity of 45 miles per hour for freight and passenger cars.
Earthwork is a major component of this project. In item number 1, there are two major cuts. Cut number 1 is right below the FedEx distribution center and it starts at station 25 and ends at station 39.5. The maximum depth of this cut is 153 feet. Cut number 2 is further down east and starts at station 80.5. It ends at station 85.5. There will be other cuts along the cliff walls of the current alignment in order to flatten the curves. This way the train speeds will be increased. We will be sloping the cuts back 1-to-1 ratio. In this slide, we show a typical cross-section of one of our major cuts in the soil.
Alignment 1 requires the construction of two soil retaining walls. Both of these walls will be soil nail walls. Wall number 1 has a length of 1,400 feet and a maximum height of 130 feet. The second wall has a length of 500 feet and a wall height of 55 feet.
Alternative 2 has some distinct features as well. The distinct features on Alternative 2 include a soil nail wall, 2 bridges, and some fill.
Along with 350,000 cubic yards of soil excavated, alignment 2 will require 2 retaining walls, 2 steel bridges that will allow the train to cross the canyon, 48 piles, and 6 culverts. This alignment will allow the freight and passenger cars to reach a maximum velocity of 59 miles per hour.
Earthwork for alternative number 2 is not as extensive as alternative number 1. There is one major cut that's also right below the FedEx distribution center. It starts at station 22.5 of the alignment and ends at station 33.5. The maximum depth of this cut is 152 feet. We will be sloping back 1-to-1 ratio and build a retaining wall whenever we cannot slope back.
Alignment 2 requires the canyon to be crossed twice. For that, 2 bridges need to be designed. Bridge number 1 is a plate girder steel bridge. It begins at point 35.5 and it ends at point 40. The total length is 450 feet. Bridge number 2 is a steel bridge as well. It's a plate girder bridge and it includes also a truss section. The bridge begins at point 73 and it ends at point 80. It has a total length of 700 feet. The truss section spans over 340 feet.
Part of this analysis includes an environmental impact study and mitigation plan. Amongst the environmental considerations, we have to think about the natural communities, the biological resources, cultural and paleontological resources, the greenhouse gas emissions, and the overall aesthetics and visualizations. Amongst the natural communities, we have wetlands and uplands. Primarily as affecting the area are the wetlands. These include the riparian woodland and the vernal pools. These provide food, cover, water, and nesting areas for wildlife. They also control the erosion and sedimentation. Amongst the plant species, we have the coastal sage scrub and the maritime chaparral. These are both home to the endangered California gnatcatcher. As well as the plant and animal species, we have cultural resources. These include a number of artifacts that were left over from the Native Americans, such as a cobble foundation left over. As well, due to the larger amounts of soil removed, there are a number of volatile organic compounds that were released into the atmosphere. Comparing Alternative 1 against Alternative 2, we see that the overall product impacts of Alternative 2 is higher than Alternative 1. Even though the soil removal of Alternative 1 is about 700,000 cubic yards, unlike Project Alternative 2, which is about 350,000 cubic yards, Alternative 2 ultimately impacts more cultural sites and more nesting grounds than Alternative 1.
Our project included a cost estimation process. This process took into consideration these main points: the right-of-way acquisitions and property easements, site civil earthwork, track work, signal modifications, new structures such as the soil nail walls, structure excavation, structure backfill, bridges, new culverts and drainage, site mitigation and erosion control plans, utility work, environmental mitigation. All of these items together produce the total project cost, which helped us to determine the best alternative. The software that we used on this project included Google Earth, AutoCAD, Bluebeam, and Google Maps. In conclusion, the advantages of Alternative 2 outweigh Alternative 1 in that Alternative 2 is the faster alignment. It requires less soil export of 430,000 cubic yards. It has a lower total project cost of about 15% less. It is aesthetically pleasing with 2 new bridges. It causes less interruption to active transportation networks during construction. It includes a shorter construction schedule with lower cost of construction to the owner. And a unique feature of Alternative 2 is that it has the potential for a future transit station that would serve the Qualcomm complex.